Welcome to the lesson, Imagining Reduction of Fractions. The series of questions in this lesson helps illuminate the reason of why reduction of fractions works. In addition to this, the exercises develop the imagination and spatial reasoning. Let's see the first example. And the question is, what part of the shape is colored green? And the prior knowledge that we assume the students to know is that this is 10/15. And this indeed is the correct answer, but now we can do as follows. We'll go ahead and choose Show Hide Line. Now, when we click and hide this line here, this of course does not change the fraction. It's still 10/15. Let's hide another line. We can also just click down on our mouse and drag the mouse to the right and hide many lines with just one stroke. And we'll go ahead and do the same. And here. And as you can see, the colored part never changed, so it is still 10/15. But now we also see that it is 2/3. The goal in class is to get as many of these insights as possible from the students themselves. Now, instead of using the Show Hide Line tool, you may also move on to the next page with the prepared solution. We see the equivalence between 10/15 and 2/3. And we can further examine the mathematical relationship between 10 and 2 and between 15 and 3. You may ask the students if they recognize this relationship, that is, the division by 5. And then if they can explain it. So an explanation could be that the 15 represents the total number of parts. When we erase these divisions, each 5 parts turns into 1 part. This is why 15 is divided by 5. And the same is true for the numerator. The numerator represents the total number of colored parts. Also, here each individual 5 parts turned into 1. This is why in this reduction, both the numerator and the denominator are divided by 5. Let's move on to another example. See what answers come from the students. Here, the idea is that we use our imagination to move these 3 parts over here. We can do this with the Color Area tool. When we click a green area in green mode, it turns white. So we turn these white and place them here. Before reduction, the fraction represented here is 12 out of 28. It's interesting to see if the students notice how this can be reduced. Try to give as few hints as possible. Let's move to Show Hide Line mode and erase this line as a hint if needed. Next, we erase here and here until the students can use their imagination and reach the answer. The solution requires erasing all horizontal lines, and we can do this all at once by clicking down on one line and dragging down and to the right. We can now see the reduction to 3/7. And, as with all questions, this visualization also appears on the following page. Again, we can point out the relationship between 12 and 3, 28 and 7. See the division by 4, and discuss the explanation in a similar way. And next. Here, different students may use their imagination in different ways. Let's move to Color Area and choose green. Now, some may imagine all the squares moving up like this. Some students may imagine them all moving towards the middle like this. In any case, before reduction, we could count and see that there are 11 out of 33 squares. But actually, this counting is not needed. The number of these columns doesn't make any difference. In any case, we can move to Show Hide Line mode and erase all vertical lines. We can also see the answer prepared on the next page. And now it's time for a student worksheet. This is a PDF file attached to the lesson. You can print it out. This is what it looks like. 6 prepared questions where the students will use their imagination and perform a reduction to reach the final answer. Let's move back to the app. These same questions appear in the following pages to allow the students to share their solutions. We'll move through these more quickly here. It's possible to use the imagination to move all of the rectangles to the left or all of them to the top. Moving them to the top looks like this. And with the Show Hide line, we click down on one vertical line and drag to the right and to the bottom. And the solution also appears on the next page. 8 over 64 is reduced to 1/8. In the next question, the idea is that the students imagine these 3 parts moving here. Now, we can hide all vertical lines and all horizontal lines. If we want, we can show these and these lines, and we can see the 4th clearly. In the prepared solution, we see that 9 over 36 is 1/4. Next, here we move these 3 to the holes. 1, 2, 3. 1, 2, 3. And we use the same technique as we saw before, hiding vertical and horizontal lines and recreating these. So we've got a negative of the previous solution, which is 1/4 is missing. That is 3/4. Next, question number 4. Color area, green. And we may move these down and these 4 up and hide the vertical lines. And we have 2/5, and the solution is here. Now, question 5 is a little more tricky visually. We take these 2 and place them here, and these 3 and place them here. Before reduction, we have 18 over 36. And here, we can do the reduction in 2 stages by hiding all vertical lines. We get 3/6, but we can also do a further reduction and erase these 2 horizontal lines here and these 2 here. And we have a half. These stages are shown in the solution. A reduction by 7, and then another reduction by 3. And next, this is the first time the shape is not divided into equal segments. We have big ones and we have small ones. Well, in any case, we can move these 3, 1, 2, 3, over here, 1, 2, 3, and these 2 here. Students, of course, might do this a little differently. In any case, once we have this block, we can imagine it moving over here. Even without erasing the rest of the lines, we can see that there are 2/8 or a 4th. Let's see the solution here. The different small parts were concentrated here, and the colors illustrate the process. Next, we see the 2/8 and the further reduction to a 4th. Now we move on to one final example. We first want to focus on the fraction before it is reduced. This is why we ask for this explanation. There are 18 colored parts out of a total of 54, and we see this here. And next, we ask the class who can explain graphically why the part of the rectangle that is colored is 2/6. For this, it is useful to move the green areas up like this. These move here, and these move here. We erase the vertical lines, and we get 2/6, and we can see this here. Beyond the graphical manipulation of erasing the vertical lines, you can check to see if the students see how this is related to the technique. The numerator represents the number of colored squares, and removing the vertical lines turns every 9 parts into 1. So instead of 18, we have simply 2. 18 divided by 9. And the same goes to 54, which represents the total number of parts. Also, here, every 9 squares turned into 1 rectangle. Therefore, we divide by 9. Let's continue here. We have the same shape, but now we want to explain graphically why it can be reduced to 3/9. See if the students can figure it out. The idea is that this time we order the green squares to the left, like this, and erase the horizontal lines. And so we have 3/9. And we can see the ready solution on the next page here. Every 6 squares turned into one rectangle, both for the numerator and the denominator. And so we have the division by 6. Let's conclude. In this lesson, we helped the students gain a visual intuition of fraction reduction. This was done here by erasing all the internal lines. We used this intuition to develop a deep understanding of the technique of fraction reduction. Beyond this, we also created problems that do not fit in straight into a ready-made technique, but require the students to use their imaginations to simplify the problem before they can use the technique. And that's it. We hope you enjoy the lesson in class. Thanks for watching.